Okay, let's dive right into this explainer and unpack exactly how data drives the real-world decisions happening all around us. We are literally swimming in an ocean of information right now, right? But here's the catch. Without a structured way to interpret it, all that data is just, well, noise. Whether you're trying to figure out a messy sales trend, launching a brand new product, or honestly just trying to make sense of a crazy news headline, knowing how to scientifically search for the truth, that is an absolute superpower. So today, we're going to decode the exact framework that professionals use to turn vague, abstract questions into hard, measurable facts.
Here is our roadmap for today. We'll be hitting 5 main stops: the quest for knowledge, measuring the variables, the art of sampling, gathering your evidence, and finally, testing the truth. Let's jump right into step 1.
Section 1. The quest for knowledge. Finding the right problem to solve. To really get this, put yourself in the shoes of Sue Taylor. She's the director of global industrial sales. Now, Sue has a rock-solid, incredibly stable base of 1,500 customers, but there's a huge red flag. They are buying less and less every single year. The symptom is obvious, right? Revenue is tanking, but the actual root cause? Complete mystery. Sue can't just sit back and observe this. She needs to actively design a research project to figure it out, because the very first and honestly most crucial step in any research is identifying the specific problem you're trying to solve.
And Sue's situation perfectly illustrates the scientific roadmap we have to follow. You start with a problem. You look at what's already known. You make a solid prediction, and then, and only then, do you gather the facts. So for Sue, after spotting that sales dip, she shouldn't just wildly guess what's wrong. She needs to survey the related literature. That means digging into past sales reports, industry trends, or scoping out the competition. From there, she formulates a hypothesis. Let's say she predicts that a rival's new pricing strategy is stealing her clients. Once that hypothesis is locked in, then she actually goes out to collect the data. All right, moving to section 2, measuring the variables, translating the world into data. Now, we have to draw a hard line here between quantitative data, the stuff we can easily slap a number on, and qualitative data, which is all about characteristics. If we're looking at things like money or distance in kilometers, we are firmly in the quantitative zone. Easy to calculate, easy to run equations on. But what if you're trying to measure human behavior? Things like someone's honesty, their marital status, or socioeconomic background. You can't just put a ruler up to those. Those are qualitative variables, and they require a totally different, more nuanced approach to figure out.
This part is absolutely critical, because how we measure completely dictates the kind of math we're allowed to use later. At the bottom, we've got nominal data. Think of this as just basic labels or categories, like the numbers on a sports jersey. One step up is ordinal data, which gives us a ranked order, like ranking your top 5 favorite cars, but it doesn't tell us the exact distance between those ranks. Then we have interval data. Think of a test score from 0 to 100. The distance between points is equal, but there's no true absolute zero. And finally, the holy grail, ratio data. This actually possesses a true zero, which means we can mathematically say things like, Ram makes exactly twice the salary of Sham.
Which brings us to section 3, the art of sampling, figuring out who to talk to. Imagine a marketing director named Manuel Banalis. He wants to know what specific product features his customers actually care about. Now, he's got 954 customers. If he sends a survey to every single one of them, he's doing a census. It's super thorough, sure, but it is incredibly expensive and honestly a logistical nightmare. The smarter move? A sample. He targets just 100 of those customers. If he does this right, the voices of those 100 people will accurately reflect the exact same sentiments of the entire 954. But how do you pick those 100 people fairly without injecting bias? Well, researchers have an entire menu of probability and non-probability sampling methods. Probability sampling, like a simple random sample, means every single person has an equal, totally random chance of being picked. Or you could use stratified sampling, where you divide the population into key subgroups first to guarantee fair representation. On the flip side, we have non-probability methods. Convenience sampling is exactly what it sounds like, just grabbing whoever's readily available. It's fast, sure, but highly prone to bias. And then there's snowball sampling, which is actually fascinating. You use this when subjects are hard to find, so you basically ask your current participants to recruit their friends or colleagues into the study.
Okay, section 4, gathering your evidence. Tools of the trade.
Once you know who you're targeting, you have to figure out what you're collecting. Are you hunting down fresh, original primary data yourself, or are you going to rely on secondary data that someone else has already put together? Secondary data is fantastic for building a foundation. Think published journals, official documents, archived research. It's usually way faster and much cheaper. But if your business problem is highly specific, you're going to need fresh, tailor-made info. That's when you have to roll up your sleeves and go after primary data, interacting directly with your subjects.
Now, if you go the qualitative route for that primary data, focus groups are an incredibly powerful tool. First adopted back in the 1940s at Columbia University, a good focus group brings together 8 to 10 strangers to hash out a topic. And that's key, by the way. They must be strangers, so pre-existing friend dynamics don't mess up the feedback. The moderator is the real MVP here. Their job isn't to talk over everyone, it's to gently steer the ship, stimulate the conversation, and extract those rich underlying opinions.
On the other hand, if you're using a questionnaire to get quantitative data, listen carefully. A survey is literally only as good as its design. If you use a double-barreled question, which is when you cram two completely different issues into one single sentence, your respondent is going to be totally confused and your data will be useless. The ultimate goal here is clarity. Your questions have to be non-threatening, crystal clear, and directly tied back to whatever your original objective was.
Finally, we hit Section 5. Testing the truth, proving it with statistics.
So before we even touch a calculator, we have to formulate what's called a null hypothesis. This is the baseline assumption that there is absolutely zero difference or relationship between our variables. I know it sounds counterintuitive, but this is the very cornerstone of scientific research. You don't actually set out to prove your own brilliant theory is right. Instead, you mathematically dare the data to prove that nothing interesting is happening at all. If your data shows a massive, undeniable difference, then you get to reject that null hypothesis and confidently say, yep, we found something real.
Let's look at an analyst named Lucy Baker. She's comparing the TV audiences of Cops and 60 Minutes. She wants to know if the demographics of these two shows are actually different. So her null hypothesis assumes the average age difference between the two audiences is exactly zero. She takes a random sample of 100 viewers from each show. By setting her baseline at zero, she's created a firm mathematical starting line. Now, all she has to do is apply the right statistical test to see if her sample data deviates enough from zero to actually mean something.
To test Lucy's hypothesis, we have to choose between parametric and non-parametric statistics. And hey, remember when we talked about those levels of measurement back in Section 2? This is exactly why that was so critical. If Lucy has precise interval or ratio data, like their exact ages, she can use heavy-hitting parametric tests, like a t-test. But if her data is just ordinal, like viewers just ranking the show from 1 to 5 stars, she has to use non-parametric statistics instead. Basically, the shape of the data completely dictates the tool you use to test it.
Ultimately, understanding all these hidden mechanics gives you a literal superpower to critically analyze the world around you. Next time you see some bold claim on social media, a dramatic chart in a meeting, or a wild new business strategy, don't just blindly accept it. Look beneath the hood. Ask yourself, was this just a lazy convenience sample or a truly random one? Were the survey questions actually clear? What scale was this measured on? By applying this kind of rigor, you stop being just a passive consumer of information and you become a real investigator of the truth. So tell me, what proven fact did you read today that might have just been a badly designed convenience sample in disguise? Keep questioning everything, and I'll see you in the next explainer.